Hello and welcome to the overview of the new features in PrusaSlicer 2.5. These are the biggest new additions: the parameter generator Arachne, the step file format support, the lightning infill, improved scene placement, and the pressure equalizer. Let's go over them one by one. For years, the strategy PrusaSlicer used when generating parameters was to offset the contour of the object with an extrusion line of a constant width. This caused issues in various cases, especially when printing thin walls, text, or logos. The developers of Cura recently implemented a new strategy named Arachne, based on an academic paper you'll find linked in the video description. The Arachne generator produces parameter loops and gap fills with varying extrusion width. Simply put, it automatically makes perimeters wider or thinner as needed. This is a major change. Before, it was nearly impossible to create a wall that would fit two parameters exactly. Now, as long as the wall thickness is close enough to two parameters, PrusaSlicer will take care of the rest. Overall, the slicing engine is now smarter. It produces nicer looking prints with less gap fill. And a nice side effect is the print times are a bit shorter. We have decided to set the new Arachne parameter generator as the default option. If you want to use the old parameter generator, you can switch to it in the settings. We were able to port this feature from Cura, because just like PrusaSlicer, it is open source. Big thanks goes to the Ultimaker Cura team and to everyone who participated in the research of this feature. Starting with this release, PrusaSlicer is able to import step files. This CAD file format is interoperable among most CAD programs, and it is an ISO standard supported by programs such as Fusion 360, FreeCAD, SolidWorks, Inventor, AutoCAD, and many more. This seemingly small addition could have large consequences. By being able to import step files directly, we expect a growing number of people to use step files when sharing the design online, instead of an STL, which is notoriously difficult to edit. On the other hand, step files can be edited quite easily, allowing for quick customizations and remixing. And businesses that do print on demand can skip converting step files from customers to STLs, saving precious time. Right now, we are tessellating the model on import. Basically, we are converting it to triangles. So the model is then sliced just like any other mesh and not analytically. The conversion is fully automatic, the level of detail is not customizable right now. We use the Open Cascade technology development platform to read the step files, so big thanks goes to them for keeping it open source. Infill has two main purposes: to provide structural rigidity and to support top surfaces. In case structural rigidity is not needed, a lot of material and printing time is saved with the new lightning infill. The lightning infill is optimized to support the top surfaces only. It generates a branching structure that gets progressively denser towards the top surfaces to support them reliably. PrusaSlicer already had an infill with similar behavior called the support cubic infill. However, the lightning infill saves even more material. When printing the classic tree-frog model, the weight of the filament is cut nearly in half compared to standard gyroid infill. Like the Arachne parameter generator, we have ported the lightning infill from Cura. Thanks again for keeping Cura open source. A 3D printer loves to extrude at a constant rate for the best consistency. Bowden-style extruders are especially sensitive to pressure fluctuations. Due to the slack in the Bowden tube, they are not able to reproduce rapid changes in extrusion rate reliably. The pressure equalizer smooths sudden changes in speed between two features. By setting the maximum volumetric slope negative to a non-zero value, PrusaSlicer will gradually slow down when transitioning from printing a high-speed feature to a slower feature. The lower the value, the smoother will the transition be. The maximum volumetric slope positive does the opposite. It creates smooth transitions before speeding up. If you're wondering what's the difference between the linear advance and the pressure equalizer, they both try to prevent pressure buildup in the nozzle, but in a different way. The linear advance algorithm changes how much filament is extruded, whereas the pressure equalizer changes the print speed, or more specifically, speed transitions between different features, such as infill and parameters. So both of these features can work together to achieve the same end result. Last but not least, we improved the seam placement algorithm. It now prefers regions that are not visible from the outside of the model at all, or which are occluded from most directions. And when paint on seams are used and set to aligned, the resulting seam line attempts to find a sharp corner in the painted area to snap to it, leading to smoother lines along the sharp edge. Also, the new algorithm strives to produce continuous seams on smooth surfaces, while the old algorithm often produced disconnected random bits in such cases. If you want to read a full changelog, visit PrusaSlicer's GitHub page. Don't forget that you can find PrusaSlicer's documentation at help.prusa3d.com. And as always, happy printing!